Hi everyone, in this quick tutorial I want to show you how you can deploy the Lambda models in an AWS Lambda thanks to a creative and hacky way of using the AWS service. Let's get started. First, I wanted to show you quickly the Lambda website in which you can find many models to run locally. Here we are going to take a look at Deepseek R1. And what I want you to notice is essentially that this is a model family. You can pull the famous Deepseek R1 with 671 billion parameters, but this one will definitely fit in the 10 gig limitation memory of our Lambda. You can find also here the stilled models, which are smaller models that yet they achieve very good performance. So the biggest one that I managed to fit in the memory of the Lambda is the 8 billion parameter one. So that's the one we are going to pull. I also wanted to show you very quickly the actual API docs of Llama, as we are going to be using them a lot. A couple things here. We are going to be using the generate chat completion. Here is where you can turn the streaming on and off. Here is how we pull a model, specifying which model we want to pull. Finally, we are not using it, but I also want you to notice that there is a way of creating a model. So it's not only about the models that are available in the Llama app, but you could bring your own model, which opens Llama to so many possibilities. Here are the results of executing our Lambda function. And as you can see, Deepseek manages to return the successful answer. I also wanted to show you how we are actually using all the memory available in AWS Lambda. Next, we are going to take a look at the invocation logs. Notice on the logs how we are pulling the Deepseek model. Then we are loading the model. We are seeing the response that the model has been successfully loaded. And then the actual Lambda invocations with our test event wise the sky blue starts. Now that you have seen it working, this is the code you can use to run it for yourself. You scroll a bit down and you find here the instructions. To deploy, simply run the deploy shell script. It's very simple because I've created everything as infrastructure as code. If you scroll a bit down, it tells you exactly what it's doing. So what the deploy script does is it first authenticates you with ECR and it checks if a repository already exists. The first time it won't exist, so it's creating one for you. And then it's building your Docker image locally and pushing it to the newly created ECR repo. The image is tagged with a timestamp so that whenever a new image is pushed, the Lambda automatically picks it up. Now that we have our image in ECR, we can deploy the CloudFormation template that will create a Lambda, and the Lambda will be using that image. Here you can see me running the script locally. When it finishes, I will show you the deployed CloudFormation template. The CloudFormation stack is now in create complete status, and if we click on the resources tab, you will notice that two resources have been created. One, our Lambda function, and two, the execution role that the Lambda function needs to be able to write logs. If we click on the Lambda function now, it takes us to the Lambda function console. What I want you to notice there is that it's actually taking our image from ECR. So let's click on that image. See how the name of the ECR repo is exactly the one that we defined in the CloudFormation template, and that our image is tagged with the timestamp. If we go back to the Lambda function console and we check the logs, you will notice a couple interesting things. First, the first time the model is run, it pulls it because it's not present in the Docker image. So that takes a while. The function is having a cold start. However, in subsequent invocations, so when the Lambda function is invoked next, the model has already been downloaded. So it's already in the cache, and the only thing the Llama server needs to do is to load it. So this is much, much faster. Hence, you can think of clever strategies like provisioning Lambda functions or using Event Bridge to keep your Lambda function warm so that your users don't experience cold starts. Something else that you will find interesting that I did on my script is to add the remaining disk space available. I'm using the maximum ephemeral storage that the Lambda provides, which is 10 gig. And at the end of the code, once the model has been pulled, I'm asking to report the available space. That's useful because while Lambda gives you the amount of memory that's being used out of the box, it doesn't do it for remaining space available. So by adding these lines of code, what I'm telling you is which models you will be able to fit, because you can see here, if you get an error, if the model you're trying to pull from the Ollama hub is too big and it doesn't fit on this 10 gig space, though you will see that you hit the memory limit much faster. How does it all work? As I already mentioned, we are using the still models, which are smaller, optimized versions of LLMs that retain most of the capabilities while reducing significantly the computational overhead. And this is what makes it ideal for serverless execution. And then Ollama enables us to efficiently deploy large language models locally. The twist here is that instead of using our local computer, we are using AWS Lambda. To be able to do that, we need to do a couple clever tricks. So first, we are increasing the Lambda resource limits to the maximum. So I'm using the maximum memory available at Lambda and the maximum ephemeral storage available. The storage is ephemeral, and that's important because you cannot bring a Lambda image with the model already pulled inside. If you want to put it on that ephemeral storage, you will need to do it at the function runtime. Then I'm setting the timeout to 5 minutes, which is more than enough, but if you're hitting timeout limits because you're pulling very big models, you might want to consider increasing. The second trick I'm doing to make sure that the Ollama server sees the ephemeral storage of the Lambda function is to change the model path. You will see that in my code. Again, the first time it takes a while because the model is being pulled and you're experiencing a cold start, but from that point onwards, the function is already warm. The third trick is I'm using a Python library called AWS Lambda RIC. Essentially, what you need to know is that Lambda containers don't automatically run Python scripts. It's not the way they are expected to behave with the Lambda handler. So we are using this clever library, which creates a runtime interface client that allows us to start an HTTP server inside the Lambda to bridge requests from, in our case, it's just a test event, but it could be an API, like an API gateway that sends the request to our Lambda. Then it keeps the Lambda process alive while running the Ollama server. You will see that there is a script that it's run at the very end of our Docker image called entry.sh, and essentially it starts the Llama server in the background, and that's very important because then the Lambda runtime will call the function in the foreground. What the function is doing is waiting for requests. Here you see an example of the API usage and how you can send a test event as well as the response that it should return. A couple things you could do. Try different LLMs. I'm showing you Deepseek, but you could try the Llama models, you could try Mistral, you could try Gemma, essentially any model that's available on the Llama hub, plus bring your own model. Second, I haven't implemented yet AWS Lambda response streaming, but that's actually possible. So I'm linking here a blog post in case somebody wants to take the challenge. Third, right now our Lambda don't have memory, right? So every invocation is separate and it doesn't remember previous conversation history. But that could be implemented if, for instance, you are using DynamoDB to store session ID. So that's a possible enhancement to the current code. If you wish to take on any of these challenges, feel free to contribute for the repo, implement the feature, and submit a pull request. Last but not least, if you like this code, give it a start. I would like to end the video with a disclaimer, which is that this is a personal experiment to explore the feasibility of running LLMs on AWS Lambda using Ollama. It's not an official AWS architecture recommendation and by no means an endorsed best practice. While this approach demonstrates a creative workaround of deploying models within the Lambda constraints in a crazy cheap way, you should consider for production-grade applications AWS managed solutions like Amazon SageMaker or Amazon Bedrock, as they give you better scalability, reliability, and support. If you found this toy project useful, feel free to connect with me on LinkedIn. I would be very curious to hear what you built.